hold music. You want to avoid it, and so do your customers. So say goodbye to hold music and hello to faster, smarter support with Salesforce. Make service more personal and agents more productive using built-in trusted AI. Then watch costs and wait times drop and satisfaction soar. Support customers in a whole new way with Service GPT. Learn how at salesforce.com/servicegpt.
Welcome to the NatureBacked podcast, where we are talking with investors and entrepreneurs about climate change and the green economy. My name is Tarmo Virki, and today I'm speaking with Yehuda Borenstein from ClimateCrop. Welcome to NatureBacked, Yehuda. Please explain a little bit what you guys are exactly doing.
Okay. So first, I would like to thank you for the opportunity to share what we are doing with you and with your audience. What ClimateCrop is doing is basically we found a way to improve the efficiency of plants and the way that they manage their energy. As you probably know, plants are doing photosynthesis and create sugars. And the sugars are basically the food or the energy for the plant, for everything it needs to grow and to support its systems. And because photosynthesis can be done only at night, only a day, the plant has a mechanism that some of the sugars that they generate during the day, they store them in the leaves at the format of starch and then consume them when they don't do photosynthesis, for example, at nighttime. So you can imagine it's like the lithium-ion battery that is attached to a solar field. And whenever you don't have sun, you still need energy. And you can take the energy from the batteries. Now, we found the gene that is responsible in the plant to give a command to stop producing starch. And by using gene editing technique, we were able to modify this specific area. And by doing that, we can increase the amount of starch the plant is storing every day in the leaves. So if you think about it in terms of energy, we basically increase the amount of energy the plant has every day. So when he doesn't do photosynthesis at night, he goes to the bank, and now we have more money in the bank. We have more energy in the bank. So the plants have more energy to grow during the night. And it's every day because every day the plant is renewing his reservoirs, his bank.
And so basically, as an outcome, the plants grow faster. The farmers can, take the crop down sooner than earlier.
Yeah. So we saw some very interesting stuff. The first thing we saw accelerated growth. We saw more yield. And then we noticed that we also saw better performances in extreme conditions. For example, drought or a heat wave. And the reason for that is that during extreme conditions, the plant stops doing photosynthesis because it doesn't want to lose water. And where he goes to the bank. And again, now the bank has more money in it. You can take more energy and the plant can survive better in extreme condition. And then following the extreme condition, because every day you have a little bit more energy, the plants recover much faster. So we saw much better recovery after a heat wave or a drought. And this is exactly what you need now in the extreme climate conditions that are unexpected and more extreme than what it was before.
Wow. How did you come up with that invention? I mean, modifying genetics is probably not something every guy can do in their garage, or?
So I definitely not able to do that. And I don't have a garage. The technology came from Weizmann Institute in Israel. The lead researcher, his name was Professor Avichai Danon. Unfortunately, he passed away about a year and a half ago. And he was leading the research, and they were looking to find the mechanism that control the starch production. And they discovered a new family of genes that were around the control for the starch production. And they noticed that one of them is kind of a little bit weird in terms of length and structure. And they said, okay, let's investigate that. So it was a newly discovered gene family or protein family at Weizmann Institute. And I basically licensed the technology from them. And two of the postdocs that did the research in Weizmann Laboratory joined me as co-founders.
Was it a long time ago?
It feels long time ago, but it was a little bit more than a year ago.
Okay.
We had a very hectic journey, interesting journey. When we just started, I licensed the technology, and I think after 2 weeks, we found our first investor. It was an accelerator in the US named IndieBio, an amazing accelerator, a very good group of people. And with their help, we actually realized what we have, because when we just started, we didn't even know what the potential and what we can do. What I didn't tell you is that all plants have this gene. So we can potentially upgrade anything you can think of, if it's corn, soybean, wheat, potatoes, and even trees. We can upgrade and give them the ability to have more yield and better behavior in extreme climate conditions.
I mean, sounds good, but I'm sure there are also a bunch of people who think that there are ethical challenges.
Yes, that's correct. When I just started the project, I didn't know anything about plants. And I heard those 3 letters called GMO, which was very frightening. When you look at GMO, there is one thing that is kind of people are scared of, which I don't think they're right, but that's what alarming usually our imagination is when you take a gene from a certain plant or a certain animal or some bacteria, and you put it in a different plant. So you bring a foreign DNA into a different DNA. But we don't have it. What we are doing, we are only cutting a certain area in the DNA. So we don't introduce any foreign DNA. And this is why, at least I feel more comfortable that there shouldn't be any concern, because this can happen naturally in nature without our, let's say, interference.
Exactly. And as you said, the kind of actually the findings were made out of the natural results, basically. Well, I mean, as you said, the beginning of the researchers' work started from finding out that there were some of the things which look different from the others, right?
Yeah, and we actually, in one of the plants that we looked at, we saw that in one of the genes that happened naturally.
Exactly.
So we are now helping nature to mitigate better the situation that we created. Okay, plants can adapt to different, but it takes time.
Exactly.
Okay? They can adapt their genetics, but they cannot adapt to what we are doing. And so we are now helping them a little bit to adapt to the situation that we are now facing.
How has the response been from the farmers' side? I assume some of them must be excited.
The farmers has almost nothing to lose. Okay, if I can give you 20% more yield without any capex, without any more opex, give you more resilience, there is no losing for the farmer. The only thing you need to make sure is that you have all the regulations in place, all the certificates, and basically, once we get to the farmer, that's the part that there is really no reason for them not to do it.
Where are you today in the process? You said you started roughly a year ago, gone through the US accelerator, get first funding, that from there have raised some more funding. I mean, how far are you from the kind of the, selling for hundreds of millions or at least for millions, right?
Yeah. So plants work slowly, much slower than what we want. What we are doing right now is that all the transformations that were done at Weizmann Institute, they were done for research purposes. So they were on model plants and not on commercial varieties. And what we are doing right now is using techniques that are considered non-GMO, like CRISPR, on commercial varieties. We started with potatoes, tomatoes, tobacco, and lettuce. And we have several projects that we are going to start quite soon, all of them with the non-GMO techniques. Well, when I say non-GMO, it depends on the region. In the US, it's non-GMO. In Europe, it's still GMO. But we are also looking on very interesting techniques that we will be able to identify and make this gene modification without CRISPR in a natural way. So it will be non-GMO worldwide. Hopefully, we will be able to present this technique and results in the next coming few months. And I think that commercially, we will be ready in 2-3 years to start deployment after we will have more data and some field tests. And at some point next year, after we will have more results, I basically will start another funding round so we can work on many plants at the same time. The idea is to go fast across the board to all the major crops.
Of course. Makes sense if that gene is in all crops, then deploying it as widely as possible. I mean, it could be that there is some certain crop where it kind of starts to fly first, but making it available is probably a good trick to kind of start off with.
Yeah, and it takes time to modify each crop. You know, it's not immediate. So in each crop, you need to learn the technique, how to modify it properly. So those things takes time.
And does the modification happen so that it will be included in the seed already, or do you need to go somewhere to do something with the plants? Or
no, it's in the seeds.
Okay.
Or basically, it go from one generation to the next generation. So once it's modified, there is no need for any additional investment. You have it ready to go, and this is what beautiful about this, because you don't need to do reinvestments every time. You just get a better plant, a new generation of plants that are adapted to the climate.
Okay, wow. And at the same time, looking at how the climate is changing and how in some regions it's changing really, really fast. I can, the dilemma you were speaking earlier about how plants are ready to change or are able to change, but not as fast as actually the nature is changing, right?
Yeah. Well, they probably, if it wasn't us, human intervention, they probably would be able to better adapt. But we kind of change the rules of the game,
Exactly. And the basically the change of the kind of climate change speed combined with nature's ability to change, those two speeds are just not matching. Wow. Is this? I mean, do you see a lot of competition? Are there other small companies building something similar, or?
So when people ask me this question, the answer is because we are dealing with a very specific gene, and other companies may be doing something else with other genes, but with the same purpose. Any competitor could be a collaborator.
Of course.
So it might be that if we combine 3 genes, that all of them are helping to manage the energy better, will give better results. Now, usually as a startup, I prefer to collaborate with bigger companies because 2 startups are usually not the best
yes.
Idea to work on. But at some point, our major competitors could be collaborators.
Exactly. And I assume kind of across the kind of agriculture-related fields, anything which improves crop yields and can make the plants more resilient to the climate change is probably a big sector, or at least strongly emerging sector, right?
Yes, and the potential is basically endless. And the challenges that we are facing is first, each region has its own crops, which you need to modify the crops that are grown in that region. You may take a soybean that is doing really good in South America, but if you bring it to Israel, the climate conditions are different, and this particular variety of soybean may not perform very well. So plants are very regional.
Exactly.
So we will have to modify a lot of them. We need to build a system that we can modify fast, we can go to market fast, and that's exactly what we are working right now. And we cannot handle regulation. So if it's a GMO, there is no chance that we can go to market in the right timeline, in the right price. So we avoid using any technique that our modification will be considered GMO. We only do non-GMO. So we restrict ourselves to regions that gene editing is non-GMO. And with this new technique that we are now trying to find, if that will work, we will be able to be non-GMO worldwide.
Good luck with that. That sounds like a good challenge for you guys this year or the coming months, right? Yeah. If you look at 2023, the new year, what are the main challenges you are looking ahead, or maybe the main milestones also?
So the first major milestone is to demonstrate the same performance that we saw with the technique that is considered GMO, using CRISPR or this other method that we are trying. So this is the major milestone, to demonstrate the same yield improvement, the same resilience that we had now using the non-GMO techniques.
And for you guys showing it, you basically need to actually plant the crops and then go and measure them through the one season, or it kind of takes more time than for the software startups, right?
Yeah, I would love it. It's we are changing the software of the plants, and that takes a little bit more time.
Yeah.
There are many things we can do quite quickly. For example, once you modify the gene, because the starch is consumed and built on a daily basis, so we can measure the amount of starch the plant is storing on a daily basis and see that we can have the increase. So that gives us a first indication that we are in the right direction. But then in order to really qualify, you need to test the plant at least for a few seasons in different climates, in different lands. There are a lot of varieties. So in order to give the farmers the confidence that what they will buy will give them the expected results, you need to build a lot of data. You need to bring a lot of data.
Of course. Good. Any concluding remarks? I think our audience will probably understand quite kind of on a big picture level what you guys are doing and what's the opportunity for the agricultural sector. And I'm sure there are some genetics listeners who are thinking that, hey, I know how to go and modify genes of something, so I'll try to tap into this great opportunity. But what's from your side?
We are very open for collaborations. Our whole business model is based on collaborating with others and with the farmers, with seed companies, with food companies. And we're all with an important mission. And here we have an opportunity to upgrade plants and give them more resilience without a lot of investment in capex, which is quite rare when you fight climate. Usually you fight climate with capex.
Exactly. Good. Thank you, Judah, and have a great 2023.
Thank you very much. We need it.
Join us again for the next episode. Thank you for listening. If you like the show, please give us a good rating and leave the feedback in your podcast player so others will find it too. We will be back next week. Turn on to NatureBacked podcast.
Hey, how's it going? You should check out Worship 95, Creating Heaven on Earth. Music to bring you into God's presence and remind you of His promises. Listen on the Autolus app or online at autolus.com/worship95.
Hi, this is Megan Kane.
And this is Jason Zook.
And we're the hosts of Psychic Visions podcast.
Have you ever experienced deja vu or wonder what life after death is like?
Or maybe you walked into an old building and got goosebumps or chills down your spine. Chances are you're having spiritual experiences without even realizing it.
Our show will cover a variety of topics from astral projection
to UFOs,
manifestation,
to the power of positive thinking and even healing energy. If this resonates with you, then this is your sign from the universe to check out our show.
Find us where all podcasts are available.
Psychic Visions, more than meets the eye.
Electricast. Electricast.